Hello, today we're going to be adding and subtracting rational expressions. Recall from our discussion of fractions, we can only add together things of the same denominator. As such, we need to rewrite fractions with a common denominator. Before combining them with addition or subtraction. This same process works for rational expressions, but with more legwork. Recall, to find the common denominator, we begin by prime factorizing each denominator in our expression. We can then use the same Venn diagram strategy that we did for numerical fractions. This time, our factors can be polynomials instead of just numbers. However, in this course, we restrict to only linear prime factors of the form ax plus or minus b. One thing I do want to point out is that x and x plus 3 as factors have nothing in common because of the plus sign. As terms, they have an x in common, but that's with terms. When you're looking for the least common denominator, they have no factors in common. So just keep that in mind when you're looking for the LCD. Example 3. Perform the following operations and write your answer in simplest form. So here, because we're adding and subtracting, I forgot to mention, don't factor the numerators till the end. Okay, so 3x over x plus 4 plus 5x plus 1 over x plus 4. They already have the same denominator, so I just add them. You get 8x plus 1 over x plus 4. Now 8x plus 1 can't be factored, and x plus 4 can't be factored, so this is all the way reduced. Okay, b. So I need to find the LCD here. First, though, remember when we had 4 minus x and I rewrote it? Well, here we have 2 minus x. I am going to rewrite it first. Negative x plus 2. Okay. X squared minus 4, that's a difference of squares. That factors into x plus 2, x minus 2. And then negative x plus 2, I'm hoping you notice it's the opposite of x minus 2. So that will factor into x minus 2 times negative 1. So when finding the LCD, I just take pairs. So my LCD will have an x minus 2 in it. And then you take all the singles. So I'll have an x plus 2 as well. And it will have a negative 1. Yeah, let me rewrite it like this. Good. So now I need everything to be that. So let me rewrite this, though, because we have x minus 2, x plus 2, minus 3 over negative 1 times x minus 2. So you'll see that the first one, we need to multiply by negative 1 over negative 1 to get the LCD. And the second one, we're missing the x plus 2. So then we get negative 6x over negative x minus 2, x plus 2, minus 3x plus 6 over negative x minus 2, x plus 2. And don't forget when subtracting fractions to subtract everything. So this will become negative 6x minus 3x is negative 9x. Minus positive 6 is minus 6 over negative x minus 2, x plus 2. Then we do need to reduce it because I can factor a negative 3 out of the top. Let me just make this a little smaller, though. So I can take a negative 3 out of the top. Then we get 3x plus 2 over negative x minus 2x plus 2. And the negatives cancel out, and you're left with 3 times 3x plus 2 over x minus 2 times x plus 2. C, 7 over 6x plus 5 over 8x. Well, let me factor it. So 6x, well, is 6 and x, 2 and 3. 8x is 8 and x, which is 2, and 4, which is 2 and 2. So again, for the LCD, we're looking for pairs. So 2 and 2. So I get 2. And then x and x, so we get an x times everything else. So 3 times 2 times 1, 2. Which, what does that come out to be? 24x. So 7 over 6x plus 5 over 8x. I multiply the first one by 4 over 4 and the second one by 3 over 3 to get 28 over 24x plus 15 over 24x, which then is 43 over 24x. And 43 and 24 have nothing in common, so I can't simplify that further. Okay. D, x over x squared minus 5x plus 6 plus 1 over x squared minus x minus 2. Now, I don't have enough room to do the factor tree, so I'm just going to do the factoring, and hopefully the LCD is obvious. So these ones, the numbers are small enough. I'm not going to do the AC method directly, but x squared minus 5x plus 6 is x minus 2 times x minus 3. And then x squared minus x minus 2 is x minus 2, x plus 1. So then if I'm looking at this for the LCD, you're still looking for pairs. Well, they have an x minus 2 in common, so the LCD will have x minus 2. And then everything else. So it'll still have an x minus 3, and it will still have an x plus 1. So that means I have to multiply the first one by x plus 1 over x plus 1, and the second one by x minus 3 over x minus 3. So then we get x squared plus x over x minus 2, x minus 3, x plus 1, plus x minus 3 over x minus 2, x minus 3, x plus 1. Then after combining the numerators, x squared plus 2x minus 3 over x minus 2, x minus 3, x plus 1. And don't forget, we have to check and make sure the numerator can't be factored. In this case, I think it can be. It factors into x plus 3 times x minus 1 over x minus 2, x minus 3, x plus 1. So this one is trying to get you because there's an x plus 3 on top, x minus 3 on the bottom. They don't cancel out. X minus 1 on top, x plus 1 on the bottom. Those also don't cancel out. So this is the final answer. Okay. And then E and F. So 3 over 22x cubed y to the 5th minus 2 over 10y to the 4th. So here, I'm just going to factor the coefficients. So you get 22 factors into 2 and 11. 10 factors into 2 and 5. So the LCD between these two numbers, without the variables, would be 2 times 5 times 11, which is 110. With the variables, the LCD is, well, the 110 x cubed y to the 5th. Okay, so we get 3 over 22x cubed y to the 5th minus 2 over 10y to the 4th. So the 22 needs to be multiplied by 5. And we already have the variables, so we just need to multiply by 5. The 10 needs to be multiplied by 11, but I'm missing an x cubed, so I need an x cubed. And since I need y to the 5th, I need one more y. So then we get 15 over 110x cubed y to the 5th minus 22x cubed y over 110x cubed y to the 5th, or 15 minus 22x cubed y over 110x cubed y to the 5th. And that's the answer for E, because the top cannot be factored. These ones I can't just factor with guess and check like I was doing before, because the leading coefficient is not 1. So we have 9 over 4x squared minus 19x plus 21 plus 4x over 4x squared plus 5x minus 21. So I'm going to start out with 4x squared minus 19x plus 21 using the AC method. So AC is 4 times 21, which is 84. Then our factor pairs. Well, they're either both going to be positive or both negative, and since we need to add up to negative 19, that means both negative. So negative 1, negative 84, negative 2, and negative 42, negative 3, and negative 28, negative 4, and negative 21. 5 doesn't go into it. 6 does. Negative 14. 7 goes into it. So negative 7 and negative 12. 8 does not go into it. 9 does not go into it. 10 doesn't, and 11 doesn't. So these are all our factor pairs. And then I'm just going, we need negative 19, which would be the negative 7 and negative 12. So then we get 4x squared minus 7x minus 12x plus 21. So I can take an x out of the first two terms, so we get 4x minus 7. 12 and 21 have a 3 in common, so I can take a negative 3 out to get 4x minus 7. So then we get 4x minus 7 times x minus 3. So there's the first denominator factored. Now for the second denominator, well, a times c is still 4 times negative 21 this time. So we get negative 84. So thankfully the factor pairs are all the same. It's just the larger number's positive. So negative 1 and 84, negative 2 and 42, negative 3 and 28, negative 4 and 21, negative 6 and 14, negative 7 and 12, which adds up to the 5 we want. So then we get 4x squared minus 7x plus 12x minus 21. We can take an x out. So then we get 4x minus 7. Take a 3 out, get 4x minus 7. Then we get 4x minus 7 times x plus 3. So that's what our two denominators factor into. Now the LCD will be 4x minus 7, because that's what they have in common, times x minus 3 times x plus 3. So I need to multiply this one by x plus 3 over x plus 3. And this one I need to multiply by x minus 3 over x minus 3. So then we get 9x plus 27 over 4x minus 7 times x minus 3 times x plus 3 plus 4x squared minus 12x over 4x minus 7 x minus 3 x plus 3. Combining like terms in the numerators, we get 4x squared minus 3x plus 27 all over 4x minus 7 x minus 3 x plus 3. And it might seem like we're done, but we still have to factor the numerator to see if it reduces. So again, I'm going to do the AC method. So AC is 4 times 27, which is 108. Then look for my factor pairs. And because it has to add up to -3, they're all going to be negative. So -1, -108, -2, -54, -3, and -36, -4, and -27. 5 doesn't work, -6 and -18, -9 and -12. 10 doesn't work, 11 doesn't work, so that's all of them. And after a quick inspection, you'll see that none of them add up to -3. So the top doesn't factor. This is our final answer. And that is it for section 9.1 part 3.